everyone. Now let's just wait for a few. I'm sure I'm audible.
Hi Manish, we can start now as well. We're just waiting for some people to join. That's all. If at all they're going to. Just 5 more minutes.
Good evening, everyone. This is week 7 of NPTEL Cybersecurity and Privacy's live sessions. I'm sure all of you have already been to one of these sessions. If not, then these are the sessions that happen as an addendum to the main set of videos that are shared with you every week. And these sessions, they're supposed uh, to help you. Okay. So these sessions, they are supposed to. I think I'm audible, right, Kanaklata? If I'm not, I'm audible, right? Is this fine, or should I even speak louder? Okay. So these sessions, they're supposed to. Okay, yeah, right. Okay. So these are supposed to add on to your to what you've learned in this particular week, and more specifically, we try to solve problems based on what was taught this week. Right. With that perspective, this week was particularly a more technical introduction to cybersecurity. Right. More specifically, it is the industry perspective of cybersecurity. So there was an expert from the industry who gave a very beautiful, compressed presentation on cybersecurity, and trust me, you won't get this kind of uh, compressed primer for technical cybersecurity in a lot of places. So it was very beautifully done, and thanks to Professor Thomas for inviting such a person. So I'm sure that particular presentation had a lot of technical aspects to it. So I would like today to be a more of a interactive session where we go through the presentation, because there are a lot of concepts in that presentation. Because there is basics of cybersecurity. So a lot of things have been compressed into it, right? So we'll go through the presentation and then we'll stop in every slide. And if you have any basic questions, you can ask and I'll be able to answer them. And after we do that, we'll move into our questions and answers. Okay. Yeah, right. So I think everything else is clear. Any questions before we move on? Logistical questions before we move on? No. Okay. So let's just. Usually we don't go through the PPT directly, but this time it's because it's a very loaded presentation. It's a lot of technical aspects to this presentation, and pretty much what are some of the things that we covered in the beginning of this course have been spoken about very briefly here, and it's kind of brought together so beautifully well. So we'll go through all of these slides and stop wherever you have questions. Doesn't matter how basic the question is. I would recommend that you ask it. If I know the answer, I'll let you know. If I don't know, I'll find out and I'll let you know. Or if anybody else knows, feel free to open up and answer the questions if somebody else asks. Okay, it'll be great if today is an interactive session. Right. So I think at one point, even we spoke about it at one of the classes where we say one of the only system which is truly secure is one which is switched off and unplugged. Right. So if you want to be completely safe, then don't use it. I think we were talking about this on something on this line at some point of time. So what is cybersecurity? Cybersecurity is the body of technologies, processes, and practices involved in protecting individuals and organizations from cybercrime, and which is now cyber warfare. So the person from the industry made a very valid point. So cybercrime is no more cybercrime; it's more of something called cyber warfare. So this is warfare between two countries, or this is warfare between one set of bad actors in a country against an organization. So it's become more about getting ahead of the status quo. It is getting ahead of the current bad actors or threat actors. It's like they're one step ahead, and then we become one step ahead. They're one step ahead, we become one step ahead. And of course, it is of course designed to protect the integrity of network, computers, programs, and data from attack, damage, or unauthorized access. So there are 5 key principles, and we've already gone through confidentiality, integrity, and availability. Right. So done this in the first few classes. So he also puts out this statistic that says the estimated damage, but it is also said that not all of the cyber attacks are recorded. In the sense, not everybody comes in reports a cyber crime that has happened. So with that in mind, so the number could be even more. The number could be even more than what is being shown here. So not everybody, because why don't they come and report? A company is forced to report a cyber crime only if the attack was so big that if people found out, that they'd lose their reputation. So if some company got attacked, they have no incentive to come and tell people, because the moment they tell people, the moment they tell the world, their reputation goes down, and people won't go back to that company again, right? So most of these attacks, they try to solve it internally, and they try to get something done in the name of mitigation or recovery from the attack, right? So that is the current state of cybersecurity, and there was one of the first cyber attacks, right? This was a logic bomb. It was explained in the class, and very nicely so. So again, so it's a good chance for everybody to get back and understand the basic concepts of cybersecurity. This is how it was structured. So we had spoken about some of these aspects briefly in the previous meetings. We can now bring them all together and see how they all go together. Okay, so some of the general concepts are operating system concepts. And so your operating systems. So these are nothing but, see, I'm going to cater this to people from the management background, because I know this course is being taken by uh, a good number of folks from the management side, right? So who may not necessarily have the technical background to understand the technical side of cybersecurity. So, I'll go a bit to the ground level and speak from that perspective. So people who already know some of these concepts, just bear along. So yeah, you have operating systems, and then you have cryptography. I don't know if you've heard of cryptography, but it's more about encryptions and decryptions. So you send a message, and this message needs to be made unreadable in its path. So this is A, this is B. You're sending a message like this, and this message should not be readable at this point. Yeah, it's just a very bare bones definition of cryptography. But that's pretty much what it is. Next is networking concepts. So OSI model, these are all the different layers of the network, and packets and protocols, firewalls. You have a simple network, and then you have connecting to a network. So you also explain something called VPNs, virtual private networks, right? And then we have security concept, which is CIA triad. What is the CIA triad? It is what this is the triad. And then they discuss how a particular virus or a malware, right, Trojan, can be executed on a target system. So what is the usual path or the attack vector that the attacker takes to successfully attack someone with a with the virus called qbot. Okay. So what is an operating system? One of the answers in the class in the main videos was you have the hardware. Okay, let's put the hardware like this. Okay, you need some mechanism to interact with the hardware. And that interaction mechanism is provided by the operating system. So the hardware is not just like this, it's going to be OS, and then the OS is going to talk to the hardware. So what are some popular OSs? We have Windows, we have Linux, right? Linux is a broad term. Different flavors of Linux are available. Okay, so what does the operating system do? It basically has the necessary code or the drivers required to communicate with the monitor, required to communicate with the keyboard, printer, mouse, disk drive, and all the file system applications, and many more, not just the scanners, all of those things. Right. So when it comes to operating systems, they have uh, 5 classes of uh, you can say 5 classifications in them. So one is process management. So every application that you see running on your system is nothing but a process. So there are processes, and a more smaller version of that is threads, and an even more smaller version of it is uh, you have execution units as well. But that's not going to that. You have processes, you have threads, then you have to schedule these processes or jobs, then you have to synchronize these processes, and then you have problems called deadlock. So these are all things that the operating system manages. And there is memory management, in which there is main memory. What is main memory? It is basically the RAM of your system. Okay, that's the main memory. This is not viral memory, this is virtual memory. Okay? Main memory, and there is something called virtual memory, which uses paging to kind of expand your actual RAM capacity. It's like the workspace of the computer. It's like when you're working on a table, your table is the temporary workspace that you have. You put everything on the table and then you start working, you start writing on it. Similarly, for operating systems also, there is something called the main memory. So if you click on a particular game or a particular application, it opens that application by loading all the necessary things onto the main memory. And then it works with the main memory in conjunction with the main memory. The operating system manages that, loading it onto the main memory and all that stuff. Okay. And then you have storage management. So this is the file system. If you go to Windows, you have the drive C drive, correct? You have C drive, and then if you are Linux, you have root slash root slash etc slash. These are two different file systems. This is Windows, Linux, and if I'm going a bit too fast or if I'm being a bit too technical, let me know. I'll abstract it a bit further as well. Yeah, sorry for that. So we have storage management where the way these files are stored, right? The encoding of the files and how is the file system implemented. It's either it's like this or is it like this? And the IO systems. IO systems would mean your pen drives, your hard disks that are plugged in. I'm saying that because it's the part of storage management, right? Okay. And then comes slightly more uh, complex things like distributed systems. How do these operating systems talk amongst themselves in a distributed fashion? Right? These are all slightly advanced concepts, which I don't think is required at this point of time. And then you have Linux, and then you have Windows. These are all, I think, this came from a part of another presentation, which was not the focus of this one. So, an operating system has multi-layer defense systems that are internally enforced. So, how do they ensure that um, defenses are enforced in the operating system? So, you've heard of something called the kernel, correct? The kernel is nothing but the most critical code of the operating system. Yeah, that is pretty much the most critical code of the operating system. And you cannot just log into your operating system and then go to the kernel and change something there. These are all highly protected aspects. Right? If you need to change something to the kernel, you need to either use LKM, which is loadable kernel modules, or you need to you pretty much need to look at the source code of Linux and then recompile the whole thing and then distribute your own operating system. So the point is the most critical code are embedded within layers of other unimportant code. So our application code is the topmost layer, which you can easily access. And then you have some device drivers. And then you have the kernel. So it is not easy for any application to go and make modifications in the kernel. And that is how the operating system is built. So moving on from the operating system basics, we have cryptography also. And essentially, cryptography talks about sending a message from A to B. We assume that there is one intruder here. That is, this channel is not secure. That's the assumption. So how can A send a message to B in such a way that anything that's in between, if the intruder even gets the message, this message is gotten by the intruder, then he won't be able to read what is there inside the message. Right? Which means the message is should be encrypted, where only these two people should have the key to it, right? And the intruder should not be able to read something. So essentially, there are two types here. One is symmetric cryptography. Next is public key cryptography. There is symmetric key and then public key cryptography. So in symmetric key cryptography, what happens is you have the same key on both the sides and you send a message. Right? You send a message between from A to B, and then you can A locks it and then B unlocks it. It's very simple. But now the question arises: how can both of these people have the same key? At one point of time, they would have had to send the key over on the network. Correct. So now the assumption is if the intruder is already there in the network, then he will capture the key. So once he has the key, then he has all the chances in every other possible way to read whatever is being sent from A to B in this channel. Correct. So this is how. So basically, you should also have a way to share your key, and in spite of someone being in between, they should not be able to guess what the key is. Right? So this is a very interesting concept called Diffie-Hellman key exchange protocol. So you use a lot of number theoretic properties, and in such a way that you don't share the actual key, but both the ends A and B will be able to derive the final key with the shared keys. Okay, we're not going to the details of Diffie-Hellman right now. It's um, just letting you know that there is something like that. So this is the key exchange part that I was talking about, and this is a part of symmetric cryptography. This next one is public key cryptography. So the most famous algorithm for public key cryptography is RSA algorithm, reversed Shamir and Edelman. So here what happens is there is A and B, but there is also a cloud repository where the public key of someone is posted. So if A wants to send a message to B, A goes to the cloud repository, takes B's public key, locks the message with B's public key, and sends it. The only person who can unlock it is B because there is a key pair. There is a public key and there is a private key. The public key is available for everybody to see. And if I want to send something to someone, I will lock my message with the public key. And the only person who can read it is that particular person who has a private key. So it's a beautiful mechanism where one key, which is supposed to be like this, has been divided by two and made into public and private. The public is public and the private is kept with yourself. And when it is um, when you need to read a message, you use the private key to unlock whatever has been locked with your public key. Right? I'm going a bit fast, I believe, but if you cannot understand, we can go a bit deeper into this as well. So let me know. And then there are also other verifying mechanisms here. You must have heard of a hash function. So a hash function helps in what? Hash function helps in verifying the integrity of a file, object, or anything you download from the internet. Okay, so how does this happen? How do you verify this? So a hash function is nothing but a set of procedures. Okay, and it's like the more you put something into it, you put some file or some image or something into it, it's going to throw out a constant sized string. Okay, and that this is the string that it throws out. So the point is, every time you send the same file A to it, it will give the same string. Okay, if you change even something, a small bit in this file, then the hash of it changes. Now again, where does this help you? So this helps where if an attacker puts into the internet saying this is A, but this A has some negative payload. It has some attack vectors embedded in it. And then you download that A thinking it is legitimate. And the moment you execute that A, it's going to rear its head and it's going to make sure that your computer is infected. So what usually happens is you download a particular file and they also give you the hash of the particular file. Now, the hash of this file would be different to what is being said in the official website. So, in that perspective, you can basically find out that that the output is different, which means they have modified something with the particular file, and you can find out that some modification has happened and this file is no more safe. And this is how you verify the integrity of the file. Integrity would mean, is the file exactly what the author intended for us to download? If it is not, then something could be wrong, right? And reversal is not possible. There are rainbow tables and there are many things to this, but let's not go to that right now. Okay, and this is the magnified view of how encryption decryption usually happens, and also hashing. This is okay. This is hashing. Now let's come to networking. So what is this OSI model? There are many layers to it, right? You must have read this in your bachelor's if you had taken the computer science stream, or if not. So basically, I'll give you context here. So there's a computer A, and there's a computer B. Correct. If you want to send a message hi, correct, and then it goes on to this wire, and then it gets received here hi. Do you think hi is just hi on the wire? No. This particular hi, this message hi, is what you generate. But on top of that, you have multiple layers, multiple headers. So you have the transport header. On top of that, you have the network header. On top of that, you have the data link header, like that. So a message that is being sent from here, say hi, will be encapsulated at all of these layers. And these, in fact, now this shows 7 layers, But in practice, we have 5 layers. So these two get abstracted into application, and that means this is all called application layer. There is transport, and there is network layer. Data link is physical. So every message that needs to be sent on the wire need to go through this network stack. This is called the network stack. Um, I think more context we can give it at the time when it arrives. Okay. And then we have network packets. So as I was saying, when you send hi, it is encapsulated, right? And it's made into something like this. So this is a network packet. So network packet contains hi, and then you have its encapsulation, which is the transport header, network header, the data link header, and the whole thing forms a network packet. So what does it look like? You have an IP packet, let's say. An IP is a network layer packet. These are all the extra information added to the message that you wanted to send. Okay. So even though you want to just send hi, you need to add all of this extra information before you send it. Why do you have to add it? To ensure that the message can reach from point A to point B. Because once you put the message on the wire, you don't have control over it. So, but the packet should reach the destination, which is B. And it is not easy because you have multiple nodes like this in between, and then B comes. Correct. So it needs to go from here to here, here to here to here to here. And if it goes like this, it's wrong. It's like it won't reach B. So this routing happens. This is all a distributed system. It's following synchronous processes. And the network packet headers make it possible. Now we look at some access control terms. So in a nutshell, access control means is someone allowed to access or view a particular resource? Yes or no? And it is done in the form of different matrices, as we saw last time, or you have many authentication mechanisms like LDAP, Kerberos, Radius, etc. And this is where you get the username and password, and then you authenticate yourself, and then you walk into a particular resource. And then you have firewalls. Now, as I said, this is the model that we follow: 1, 2, 3, and then 4 and 5. So a firewall can operate in multiple layers. It could either operate in 5, 6, 7, or it could operate at level 4 or level 3 or level 2. So what is a firewall? It is nothing but a glorified filter. So you have a firewall, You have some input to it, and then it gives an output, correct? And then you're feeding some rules to it. So whatever input the firewall gets, it compares the rules. If the rules say yes, allow, then it allows. If it says no, then it denies. That's what a firewall does. And packet filtering. So here the input is going to be packets. Output is going to be packets only. If it is allowed. If it is allowed, then the packets are being outputted. That's all. So let's take this example. Let me just draw the demilitarized zone. So this is your trusted network. This could be your campus network or your company network, which is having its own administrative domain, and it is called as a trusted network. Now, before you let anything enter your network, you have a firewall here. Now it checks every packet that comes into the network, and if it does not comply with a particular rule, then it blocks it. Correct? So this is pretty much how packet filtering works. So these are all, I think, slightly technical. So you have a DMZ also over here, which has the set of servers that kind of serve the organization. Um, but the concept remains the same, right? You need such filtering mechanisms to filter the data to make sure that attack packets don't get it. Now, VPNs, most of you might be using VPNs. So what VPN does is you basically ask another system, another computer to fetch what you want and give it to you, in the sense that that particular system is going to do your job. And so if you are A and then you want to access B, you can directly ask it, or you can ask a proxy where this will fetch whatever is you being asked, and then this will give it to you. Now these are done for many reasons. One is geographical locks. Suppose if you're not in your demilitarized zone, right? If you are not present here, then you won't be able to access what is there in the internal network. So for that, you need to access a system that's in the internal network and access the resources through that. So this is what happens when you log into your company's VPN. When you say you log into your company, right? You're logging into your company's resources from somewhere outside, sitting physically outside. They all use this VPN concept. So when it comes to a cyber attack, you have multiple phases. The first is reconnaissance, where you look at the attacker, sorry, where you look at the victim. Then you find out what are all the different activities that the victim is doing, and you find out where are the weaknesses. You identify the vulnerabilities, and then you go ahead and then you execute your plan of attack, right? And I think it was explained better than I could ever in the videos. So let's just move on from this. So we have untargeted attacks, which I think we spoke about last time, uh, called phishing. Correct? Phishing is an untargeted attack. And then you have focused attack, and an example of this is spear phishing. And then you have some basic concepts called confidentiality, integrity, and availability. I think we've spoken about this as well. Any attack tends to mess up either this or this or this or all of it or some of it. So in one of the previous classes, we things like remote access administration tools, RATs were spoken about, Trojans, keyloggers, ransomware. We touched upon all of these aspects. And then social engineering, we spoke at length about phishing and spear phishing. And then we spoke about, I think we did speak about this, but I did mention that you have a botnet of devices, zombie devices, which have been uh, compromised. Right? Then you have a man in the middle attack, and then denial of service and distributed denial of service. We spoke about all of these attacks at one point. If you have questions on any of this, please feel free to ask in the chat. I can explain them from scratch again. So again, we've looked at a different diagram for this. So here it is a more war zone diagram. This is the okay. This is the bunker, correct? Then you have this thick concrete, but what happened here is there was a small exploit. I mean, there was a small weakness here, a vulnerability, which was exploited, and the bomb was sent inside. And the bomb is called the payload. Okay. So this is the internet. The internet is where the payload is dropped from. So this is like the vulnerability led to the exploit, um, and the exploit led to the payload being delivered to where it's supposed to be delivered, just inside the heart, and then it blows up, and the whole bunker is dead. Someone was asking about remote administration tools, remote access tools called RATs. Some of them are benign in nature, but anything that's benign in nature can also be used for malicious purposes. And some of them are not. Some of them are designed to spy on someone's computer without their um, without their consent. And then you have keyloggers. We even spoke about keyloggers. So keyloggers are nothing but software that can record your keystrokes, and it'll come back, and then all of your data is gone because you type your password somewhere and then your password is out. And this is how a command and control panel looks like, and I think it was explained in the video, so we don't have to go through it. And the point of doing this is at any point of time, if you have any questions on any of these concepts, you can ask. Okay, and then it was beautifully explained how the ecosystem or the market of cybersecurity works now. Um, and this was an interesting diagram. We had seen something similar before. So how does someone get a particular Trojan onto someone's computer, right? So the victim sends a phishing mail to the target, and this is more specifically like spear phishing. So the email has an attachment, and the attachment could be something that is as simple as a Excel file. But what these Excel files have are something called macros, which means they run some code. And these there are completely benign codes that run, and there are completely malicious codes. And what does a malicious code do? It runs a macro which downloads some executable file, some code from a from the attacker server, and that's the code that is there inside the Excel file. And once this executable file or this DLL file is downloaded, it okay, DLL is okay. Let's make this into an exe file. I think you're all familiar with exe, correct? Dot exe file. But once it's downloaded um, and and executed, it loads all the components of the virus onto the system, and it does. It could do any of this, right? and your computer becomes a part of the botnet. Okay. Now for malware analysis, um, you have some techniques and advanced persistent threats, and these are all some of the top attack trends. And if you notice, web application attacks are also quite common. These are all some crime groups, and all of this information is very, very interesting from the perspective that it's 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 from the current scenario, right? Okay. Um, so that would be the recap of what happened this week. Now let's look at the questions. I just write it down and then discuss it. So which VPN technology uses leased circuits from a service provider and conducts packet switching over these leased circuits? And by circuits, they just mean networks. Correct. So basically, they make use of an intermediate network through which they help their clients access resources that they previously could not access. And that could be either some websites or that could be either your own company resources. By definition, the answer is trusted. They're called trusted VPNs. Okay, so that is the answer for the first question. So you have these biometric scanners, right? So what do? These biometric scanners, the moment you put your fingerprint on it, it either say yes or no. Correct. So here I would like to introduce the concept of false positives and false negatives. So let us say it's I'm putting my fingerprint and I am legitimate in the sense I am actually there in the system, and I put my thumb here, and then the machine says no. But why would it say no? I'm supposed to be in the system, right? So this becomes a false negative. It shows a negative, but that negative is false. That's the easier way to understand this. At the same time, if I am not in the system, and if I put my finger and if it says yes, then that becomes a false positive. Now the question is, which is more dangerous in the context of biometrics? Is it false positive or is it false negative? So let's look at the consequence of a false negative. If I'm actually supposed to be inside the system and if I get a no, I'll try again until I get an yes. Okay, so that's fine because I'm supposed to be allowed. But if some random person comes and puts the finger and then it gives a positive, that means access has been given to someone who is not supposed to be there. So false positives in this context, especially in the biometric context, is more dangerous. Correct. So this question asks something on this line. The biometric criteria that describes the number of legitimate users who are denied access. Legitimate users who are denied access. So they are legitimate, they are correct, but they are denied access. So what is this? This is a false negative. Denied access is negative. Okay. And because of a failure in the biometric device is known as false. So you have false here, but negative, which is reject. Reject is negative, accept is positive. So the answer is A. Okay, this is how you get the answer. So basically, it's the false reject rate. So they are saying all traffic exiting from a trusted network should be filtered. This is a trusted network. And this is its border router, let's say. Then you have many nodes here, correct? So essentially, what they have to do is any traffic that comes into a trusted network needs to be filtered. Anything that goes out need not be filtered because a trusted network should not be penetrated into. That's the point of a trusted network. So it's the opposite. So therefore, the answer is false. Okay. So essentially, what happens is when there are critical systems involved, if a company has a major server here, correct? What they do is, as a public facing server, they put a decoy. So when attackers think they're attacking the original system, they end up attacking a decoy. Right? This is called a decoy. And this decoy is nothing but a copy of something that is not important. For that, actual systems or actual servers can be protected. And the name, the common, the industry accepted name or standard name for this is called as a honeypot. Okay, the answer is honeypot. Signatures. This is signatures. So signature based IDPS. So what is this IDPS? Intrusion detection and prevention system. An intrusion is an act of intruding into a trusted network. Correct. So first, the IDPS, what it does is it detects an intrusion and then it prevents the effects of the intrusion. Right. So this is what happens in a signature-based IDPS. But how can you detect an attack? Based on what will you detect an attack? Because if I'm sending some traffic, an attacker is sending some traffic, what is the difference between both of these? The difference is when the attacker sends some attack, like a DDoS attack, it has some characteristics to it. A DDoS attack will probably have a huge number of packets. very less intra-arrival time between the packets, or their flow characteristic will be different. So there's something that's different in the attack vector, and that is called as a signature of the attack. So if you can identify that some signature is happening of this sort, then you can say some attack is happening. And that is what is being said here. Signature based IDPS technology is widely used because many attacks have clear and distinct signatures. The answer is yes, true. It is true. That's what IDPS does. And if I'm moving too fast, I need you people to let me know that I'm moving too fast so that I can slow down. This question, I think you'll all know the answer to. Right? The method by which systems determine whether and how to admit a user into a trusted area, correct, of the organization is known as, is it attribute, is it accountability, is it access control, or is it auditability? It is access control. We just saw, right? How do you authenticate someone and put them in the trusted zone? Correct. So this is a very direct question. Dash denotes the rate at which fraudulent users or non-users are allowed access to systems or areas as a result of a failure in the biometric device. This failure is also known as dash. So this is similar to that false positive and false negative. So they say denotes the rate at which any user, fraudulent user or legitimate user, are allowed access systems or areas as a result of a failure in the biometric. Okay? So they are allowed access. These are the keywords. So they are falsely allowed. So what is it called? It is false accept rate. And this false accept rate is also called as a type 1 error. And the eighth question is similar to this. Okay. Dash denotes the rate at which authorized users are denied access to systems or areas as a result of a failure in the biometric device. Now, this failure is also known as what? So, at which authorized users are denied access. So, it is a negative. What kind of negative is it? It's a false negative because users who are supposed to be given access are not given access. So it is a false reject rate. And these are called as type 2 errors. Okay. Because see, I didn't have to read the rest of the lines, just authorized access who are denied access. So it's as simple as that. Dash Okay, so Dash initiates network traffic to find and evaluate service ports, whereas Dash uses traffic from the target network segment to evaluate the service ports available for hosts on that particular segment. So essentially, there are two types of. So they're talking about vulnerability scanners. So what these scanners do is they look at network ports that are open on all the hosts present in the network. So as one way to do it is active. The other way to do is passive. So the first method that they're speaking about here are active vulnerability scanner. The second method is passive. Okay. So the difference is to find out such vulnerable ports or unnecessarily open ports, you send direct probes. By probes I mean direct network traffic to find out if something is open or not. And this could be from outside the trusted network also. But when it comes to passive, this passive vulnerability scanning, what it does is it uses traffic from the same segment of the network. Thereby, it will be difficult for it to detect if somebody is even trying to scan your network. So passive scanners are a bit more stealthy, and that's pretty much it. We've covered all the questions for this week. If you have any questions, you can ask me. Uh, we can end the call in a few minutes. You're free to leave if you don't have any questions. Okay, so as I see, there are no more questions, so we can end the session today.